Okay, this is our second optional presentation in Module 3. It goes with Lab 1, which is this superfeed problem, which has a pretty extensive handout with lots of sort of discussion, and so it's an assigned reading as much as it is a handout, or a lab instructions. And there's just a couple of things I wanted to sort of talk over the layout of the spreadsheet, so it could be kind of hard to follow from the handout, and just a few other things on the logic of the lab, why we are going through these steps. That there are some things about modeling that always hold. They're right at the top of the lab handout. I just want to be sure that we understand the idea that as we add activities or add choices to an existing problem, we can only make improvements. The decision maker can only be helped by having an additional option, because they always have the option, they always have the alternative of ignoring this new option. Now, this is a piece of, this is a legitimate question in economics, whether that holds up. So I'm here to tell you, in the models we're building, adding an activity doesn't complicate things enough for our choice makers, our decision makers, because the spreadsheet, the solver, says, I can quickly add this alternative, I can think about it, and I can make the call for you that it's better or it's not better. For people in real life, having their choice set doubled can be sort of noisy, right? And so it's a real piece of investigation, especially in consumer economics. How much is too much information, right? Is getting a third or fourth variety of wheat with slightly different characteristics, is it something that is welfare improving, or in some context it can only help you lower the cost of whatever it is you're trying to do, but there could be sort of a psychological cost or some indecision cost associated with getting a space for a decision problem that seems too large. Obviously, human behavior is very much a piecemeal kind of activity. We separate. We think long run, right? What is the amount of money I'm allocating to savings or retirement, holding aside for a college fund? We think medium run. What kind of durable goods expenditures am I going to have to make? Are we going to be on the car market in a year or two, or new refrigerator, freezer, washer, dryer, those kind of things? And then we think short run. I'm getting ready to go to the grocery. What is already in inventory, and what am I going to buy, and how much money can we afford to spend this week, or what's the proper sort of allocation to the grocery items this week? And so people break those problems apart, and so we get all kinds of sort of corruptions between what we call pure optimality in a quantitative setting and how people behave. But that doesn't change the fact that in these quantitative models, we know what we're going to get. Okay, so we are substituting mathematical algorithms for people, and so part of the reason to do these things is to demonstrate that additional options, you should be able to generate improvements. We had some really good research going into this kind of thing out in economic sciences, especially on these sort of psychological costs for decision makers, and obviously for decision makers under risk. How do they deal with multiple options to mitigate and those kind of things? We're not going to deal with those problems. We have these general conclusions. If I give someone more opportunities in general, that should be welfare improving. At worst, it should be no change. If we start laying a bunch of extra constraints on someone, Well, that should be welfare reducing, or betterment. Uh, it should have a negative impact. At worst, or sorry, at best, it has no impact. Right? So the more restrictive something gets, the worse off you are. The more it goes in the other direction, the better off. And sort of the classic case of a constraint is you make income in tax bracket B, and they change the top tax bracket C. They doubled the rate on income there. Well, the world got more restrictive. It just didn't happen for you, right? So there's a new constraint, but it doesn't really bind you if your income is in the lower bracket. And so that's the classic case. Now, if they do change the brackets and push it down, then there's a new constraint impacting you, and you'll be made worse off. Okay, so this superfeed problem is one I've had a lot of success. It's a homegrown problem, working with some students in the past to really get them oriented to the idea of, let's start from a legitimate solution, a stable solution. So it's scenario-based sensitivity, scenario-based investigation. Let's start from a stable solution. We have this producer, this decision maker out here who buys feed, and they buy prepared feed. And they pose the question, could I mix feed at lower cost? Well, the first question that would have to be asked, so obviously there's a capital component. You need to be able to mix feed, right, and probably do it with a machinery complement. But the first question is, can I actually assemble the nutrients, right, the ingredients at lower cost? And that would give you, if you can, then the difference between that and the per pound price of this super feed, this mixed feed that we're already buying, would give you an estimate to go work with on your next stage problem of sort of a capital budget. But anyway, we start from this stable solution. I buy this feed right now. We add options incrementally, and then we look for changes in the solution and try to identify why they happen. Since we're doing this in incremental, we already know the sort of big picture why this happened. Well, you added an option, right? So we're adding these options. You add this new thing, it changed the solution, and it may be the case that it changes the solution in more ways than just the one shot that happened, and so we have to sort of build those out. This is a classic instance of model building. Hopefully it's something that would I don't know what a lot of you are doing on your projects yet. I've been started looking through some of your little summaries in hopes of trying to interact with you and get some feedback going, right, trying to do a module with you and have you think about, is this something, did we learn anything in this past 2 weeks that would help as I start thinking about capstone? And so we will get into that, but it's this classic instance. So does your firm have some sort of current strategy? Is there a way you could fit that into a solution, fit that into a optimization model where it presents as the solution so that you could start trying alternatives from that solution and get sort of pure or incremental measurements of the margin that's created when these new options are done? Because typically those new options come at costs, and we may not know the actual cost, but what we can do is get an estimate of how much money would be available, how much savings are created by the option that could go towards implementing it, right? And so that's sort of a classic model building case. Here we start from a known, declare it to be the optimal, set the optimization model to reproduce it, and then we start with what we call counterfactuals, or these increments. So counterfactual, something we're not currently doing, but let's set it up as an alternative and see if it works or if it doesn't work. We add those and we keep looking for changes in the optimal solution, trace those out, and then it becomes this sort of useful, as I've been talking about, way to link models together. Another one would be a firm optimizes based on resource availability, and now let's say that the government is considering cap and trade. That's potentially a new constraint, but also a new open market for trading in emissions or something. And so that's something that I have had a little bit of experience with. Some other people were working on, and I helped on some of the modeling, on representative agents and who is more likely to be a trader, underneath their cap enough that they're out there selling in this new market, and how restrictive is the cap for people who are sort of high emissions, and how much of a tax is it on them. Okay, so that's the basic sort of concept around this lab. I tried to write it out in the handout, but with that, let me just show you how you would go through the steps here and how it's sort of laid out in a spreadsheet. Okay, in the lab, you'll see you start from this sheet called Lab 1A, and it's the superfeed problem. It's the only choice here. Okay, and so one of the things you could do is say this is built on a one unit of superfeed. The price is 200 cents, or I'm not sure. I think it is 200 cents, or it could be $200 a ton. I'm not sure. Sorry, but that's we know it's 200. That one unit costs exactly 200, and that one unit meets all of these constraints. So really, instead of saying what are the protein requirements, calcium requirements, and iron requirements of our animals, instead of doing that, we're taking the current values, right? We took these values here, sorry, the right-hand side values. We took these right-hand side values exactly from the superfeed quantity. And that's basically saying, okay, we don't know exactly what the minimum targets are, but we know what you're currently feeding. And so the idea is, can we build an alternative feed that is as good as superfeed, in that it provides these same nutrients in these same amounts and has lower costs? So these are not referenced out to some recommended daily intake. They are referenced to the fact that the optimum you currently are enjoying, the choice you're currently taking on, is this feeding ration. Okay, and if this feeding ration is okay, then we know we can set that up as the constraints and work from there to think about our alternatives. Okay, so if you set this to 0 and let Excel solve it, I'm quite sure it's going to solve. I believe I have most of these set up, so they'll just solve for you. You'll see everything to be binding. I think one of the things that is kind of interesting as you go through this, sorry, that it's not on a screen you can see. If you open the sensitivity to these and look at the sensitivity reports, you'll start to get these kind of odd results. I'm gonna pull that apart, yeah. Where you have a bunch of binding constraints. Everything here, the left-hand side, or the final value, matches the right-hand side. Sorry, this is bugging me. Left-hand side matches right-hand side, but only one of these produces a shadow price. It's because there's a bunch of constraints meeting up in the same little corner point. So you need new alternatives in this model to get more than one shadow price, and I think the handout kind of talks through this idea. You know, that the shadow price here is kind of interesting in some sense, but also a little bit weird, because they could have calculated the shadow price for this one instead of this, right? So you only get one shadow price per activity choice because of the way the problem solves, but it's not clear why Excel chooses to give you that one versus some other one. Okay, so that's the 1A. You reproduce this base solution. 1B says, okay, let's add our first ingredient, corn. If you solve that, which you're asked to do, you would get, I believe, a solution that returns superfeed. And as you work through that, the handout kind of describes what you're seeing. If you add corn and beans, I believe you still see that superfeed is superior. There's no mix. There's no bringing in these other goods, or no mix of corn and beans that lets you feed less superfeed. Then finally, when you get to 1D, I believe this is the one that'll generate a new solution, and you can get what that is. Then the last one, there's a bunch of questions you're asked to deal with in this lab quiz, and so that's the one I want to tell you about. And so let me go to Solver, or I want to walk you through just a little bit of it here. And so it says the objective cell is G4. That looks correct to me. We're going to minimize. We have the constraints in. It's an equality constraint for that one. So let me change that. I think I want to set it. Oops. I'm going to change it to less than or equal to just for the heck of it. Okay, so I basically have what now would be the Lab 1D model set up here, but I need to add the variables. So let's go here, and the normal strategy for putting in choice variables is to highlight all 5 of these, click OK, and then click Solve. And now we click OK. We're going to save these results, and you get this solution. So you're overshooting a few of the constraints here and there, but the key result, right, the thing we were looking for is, could we replace superfeed? And it turns out corn, beans, oats, corn, bean, and hay provide you the same kind of nutrition content so that you can actually lower this cost by 32, 33 cents. Now, if you wanted to solve this model and think of only beans, oats, hay, and superfeed as the choices, well, you could change it and select only these. But what if I said, do a model that is corn, beans, hay, and superfeed here? Well, your inclination might be to delete this column out of the model, and I'm going to tell you not to do that. So just one thing that we haven't covered yet in Excel that I need to cover with you is that this changing, sorry, let me do that slower. I'm in the by changing variable cells space right here. And so one of the things you can do when you're selecting the variables is actually click a cell and then put in a comma. And so I could put in corn and put in the cell for beans, another comma, hay, another comma, and then superfeed. And now it's giving me those 4 choices. It's skipping over the oats row. Okay, so this is not going to be an adjustable row, and so as long as it's set to 0, everything is fine. Okay, and so we end up getting the same solution, just with a different thing. And so I think there's some steps, some tasks you're asked to do in the lab quiz where you'll need to do this, right? So instead of building a new model and cutting out a column every time, this is how you want to do it, right? You want to go in there and select individual cells and put a comma in between them, and that'll let you let you do that. This can be used for several things. What if you wanted to have this quantity of oats in the solution forced into your solution? Then one of the things you could do is say, okay, I want to set that activity level here as sort of a fixed amount, right? And so you'll get all the contributions that go with it. And you could come up here and solve, and since I left oats out of the solution, it'll solve for a new value, right? So what kind of solution do I get when I force oats to be a value of 0.01, right? So the lowest cost accounting for that fact. Now there's one issue here that's kind of important to think about when we do something like that. I'm essentially saying I have a new constraint for my model. I'm now saying that oats, maybe because I have some on hand and I need to get it fed, I need to figure out a ration that uses this this amount of oats that I have. We should price it accordingly, right, according to its opportunity cost. But we are forcing the model to feed it, but we are not putting it in as a regular constraint, so we're not going to get a shadow value on the fact that we're saying you must feed at least 0.1 measure or 0.1 units of oats in your mix. Okay, and so while this is great for a quick test to get the change in the objective, I think the more proper way to do it is put in the constraints and actually get the shadow price reported, rather than try to say, I know what the value would be if this was allowed to go to 0, and that would be the solution we had before. right? It would be the objective cost when we didn't force that in there. And yeah, so we probably know what the shadow price is directly from that calculation, but the best way to do it is always put it in as a formal constraint. So it's great for testing and sort of getting a quick look of, do you get this new solution change, or does it even matter? Is it a binding constraint? Well, it certainly is, and so if you put it in there, you would find it. With that, I think I'm going to shut down. The main thing I wanted to do was talk a little bit about the logic of this lab and how it fits into the sort of bigger picture world of becoming sort of critical thinkers who look at economic problems as these sort of mental models, and who already know some results, and being specific about those sort of pre-known results, and those being, you make things more restrictive for me, you're adding burden to me, right? I may not realize it in extra cost, but I know that you've shrunk down my choice space. You give me new options, I know you're expanding my choice space. I may not adopt those options right away, but I can't be made worse off by having those. And then this second thing about this quick little note that is not in the handout that lets you know that you have this option for adding in, picking and choosing which variables in the column here, so you don't have to do that. So I think the way I've built this out between 1A, B, C, and D, I might have given you the impression that you always need to do a new spreadsheet, but you can do lots of tests with the same one by picking and choosing which activities enter into the solution. With that, I think I'm going to close it out and wish you good luck working through the lab and the lab quiz.